what the heck that thing gives you. Now let's think about this. Our unit circle gives us cos of an angle, sine of an angle. Now I was talking to you about the unit circle and I said, okay, if you wanted cos of 45, let's say, you go to the 45 and you take off the x, which is root 2 over 2, okay? What if okay, and so the unit circle formula, if I said, okay, what's the point at 45? You're just going to go to 45 and you're going to tell me it's root 2 over 2, root 2 over 2, right, at 45 degrees. What happens, though, if I ask for it on the unit circle, but it's not one of our reference angles? So, for example, what if I asked you for the coordinate at 12 degrees on the unit circle? How did you check at 60 degrees? What did you do? You went, what first? Cos of 60, someone was saying it, and then comma, sine of 60, correct? And then you could check it and you could do exact values based off your decimals if you want to. But you could find off your unit circle. But what if I said 12 degrees? Oh goodness, it's a new thing. Yes! Cos 12 degrees though, right? Yes. We could go cos 12 degrees, comma, sine 12 degrees, and they'll either have it written like that as a multiple choice answer, which would be a little bit more of a giveaway, or they'll go sine 12, cos 12 to mess you up, put them in the wrong order. So it's Calgary Stampede. Okay? Or they'll say this is A, this is B to 3 decimal places. What's the value of A plus B? What's the value of A times B? What's the value of A? What's the value of B? And you need to know that if I ask you for the coordinate off a unit circle, it's cos of that angle, sine of that angle, right? That could be the coordinate. Yes? Okay. So if I go back to here, sorry, I got ahead of myself. If I go back to here, it says state. State means give me an answer. If I say determine, you have to show some work. If I say state, an answer is sufficient. You go to your unit circle, pull the answer off, boom, call it a day. Okay? Difference between state and determine. Determine is show some mathematical work. So here, it's state the coordinates of the intersection of the terminal arm and the unit circle and pi over 2. So go to pi over 2. What is our coordinate? Your unit circle should be handy. It's going to be your best friend from now to eternity. What's your coordinate at pi over 2 at 90 degrees? What's the coordinate? It's cos of pi over 2, sine of pi over 2. What is the answer, though? It's on your unit circle. Just read it off.
0, 1.
0, 1. It is. So, do I want you going directly to your calculator? No. I want you to go to your unit circle and then you can check it with your calculator. You should walk away knowing you're right or be sad. There's no in between. Okay. Negative 3 pi, is that directly on my unit circle? My unit circle only has positives. It's 0 to 2 pi. But let's think about this. Everyone put your calculator down. Talking about yesterday, we talked about coterminal angles, correct? Coterminal angles terminate at the exact same spot, the exact same coordinate, correct? So if I can get the coterminal angle that goes with that, that's from 0 to 2 pi, can I not just pull it off my unit circle? Because it would terminate on the exact same coordinate, would it not? So, how do I go about getting negative 3 pi to be between 0 and 2 pi? What do I add to it? 2 pi. Negative 3 pi plus 2 pi is negative pi. Is that on my unit circle? It is on, they're all on the unit circle, but is it on the 0 to 2 pi portion? No, so what do I have to do again? Add 2 pi. Negative 1 pi plus 2 pi is? Pi. What's the coordinate at pi? Negative 1 and 0. So guess what? Listening? Pencils down. You can write in a second. The coordinate at negative 3 pi, guess what it is? Negative 1, 0. The coordinate at negative 1 pi, guess what it is? Negative 1, 0. And guess what it is at pi? Negative 1, 0. Because negative 3 pi watching me if I have a unit circle on either. So if I went to go do negative 3 pi, could I not just envision it as well? Negative 3 pi, everyone's paying attention to me. If I went and did negative 3 pi, this would be negative 2 pi, right? This would be negative pi, negative 2 pi, negative 3 pi. Lands on pi, does it not? Negative pi, negative 2 pi, negative 3 pi. So I could actually visualize it as well. I could rotate around. Yes? Okay. Often just adding 2 pi till it gets you there also is faster because it's just like less brain work. You just find the coterminal that fits between 0 and 2 pi. So a lot of people that struggle are the people who try and visualize it, or the people who cannot visualize anything outside of 0 and 2 pi. If you can't, cool. Find the coterminal that lands between 0 and 2 pi, then you don't have to envision outside of it. Yes? All right. 7 pi over 2 is too big, so I'm going to have to subtract 2 pi's. 7 divided by 2 minus 2, and you'll get 3 pi over 2. Or you can make a common denominator. You can go 7 pi over 2, and then this would be times 2 and 2. So it would be minus 4 pi over 2, which is 3 pi over 2, which is on your unit circle. What is that? 270. 0 and negative 1. 720, you could envision it going like 360, 720, and it lands on the same spot as 360. Or could I just find the coterminal? It's too big, so what would I do? And it's in degrees. Subtract 360 degrees. And then I'm going to get 360 degrees. And the answer at 360 degrees is 1 and 0. Yeah? 2 more rows for you. Go. You do not have to do L. It's a repeat. I'm going to go through some of these. So 60, you could do cos of 60 sine of 60, or you could look up your unit circle, and you should get a half and root 3 over 2. 7 pi over 6, you should get negative root 3 over 2 and negative a half. 240, you should get negative a half and negative root 3 over 2. Negative 330, you could envision it landing on 30, or you could add 360 to it, and it would get you 30. That would get you the same answer, which is root 3 over 2 and a half. Negative 5 pi over 3, we would add 2 pi to it, which is negative 5 pi over 3 plus 6 pi over 3. You want to make common denominator, which is just pi over 3, which is 60. So it's a half and root 3 over 2. But remembering, I could check all of these. I could go cos of negative 5 pi over 3 in radian mode, right? And sine of negative 5 pi over 3 in radian mode. It would still give me the same answers. 9 pi over 6, I could subtract 2 pi, which is the same as 12 pi over 6. So I get 7 pi over 6, which we've done already, right up here. Negative root 3 over 2 and negative a half. Negative 570, I have to add 360 to it. So I get negative 210. Still too small, so I add 360 again, which gets me 150, which is the same as negative root 3 over 2 and a half. Make sure when you are using degrees, you have what? Degree symbols. If you don't put a degree symbol, what are you telling me it is? A radian. And you're like, well, Ms. Lepp, you know better. No, I don't. There's not a degree symbol. So please, put the degree symbols. All right. Now I'm going to give you the coordinate, and I want the angle. Now look up here. It says, determine the value of angle theta in standard position. So I want the angle that gets me this coordinate between 0 and 2 pi. So if you're like, okay, it's at 210 degrees. Cool. I asked for it between 0 and 2 pi. Does 210 degrees fall in there? No, that's radius. So if I look at the coordinate negative 1, 0, go look on your unit circle. Where does negative 1, 0 happen at? A lot of people tell me 180 degrees, which is wrong. It's pi. Why is it pi? Because my restricted domain is in radians. So my answers have to be in radians. Remember, it doesn't matter what you like. It does not matter. It matters what it's in for restrictions. Okay, root 3 over 2.5. I know for a fact. So I have people doing this. Root 3 over 2.5. And they start looking at the bottom. It's positive root 3 over 2 and positive a half. At minimum, where should you only be looking? Quadrant 1. They're both positive. The only place you're both positive in is quadrant 1, right? Don't go sitting in 3. Why are you doing that? So root 3 over 2.5 falls on the very first pi over 6 reference angle. And it is pi over 6. Now this one, going back to grade 11. That is not specifically sitting on your unit circle perfectly screaming at you. However, every answer on your unit circle you have rationalized, which means you have no radicals in your denominator. You were taught how to rationalize last year in 20-1. So when you have a monomial radical, you multiply by itself, because root 2 times root 2, remember when you multiply radicals? You multiply the radicand by the radicand, yeah, what's underneath by what's underneath. So root 2 times root 2 is actually root 4, which is 2. So that's why you multiply by itself, because it gets rid of the radical, right? So root 2 times root 2 is 2. Can you just randomly multiply a denominator by something and be like, ah, it's the same. It's equivalent. The only way it's equivalent is if you do the same to the top. So it's actually negative root 2. So 1 over root 2 is the unrationalized form of root 2 over 2, which you do have on your unit circle. Yes? So this is the coordinate the same as negative root 2 over 2 and root 2 over 2. What quadrant is your x positive and your y negative? Try again. What quadrant is your x negative and your y positive? I said quadrant 2. At the 45 or the pi over 4 reference angle. So it is at? Yeah. Negative a half, negative root 3 over 2 we know is in quadrant 3, because both of them are negative. Whenever we start with a half, we know it's a 60 degree or a pi over 3 reference angle. So I just look at the bottom one. So it's going to be? Yeah. Oh wait, flipping over. So I can give you the angle, ask for the coordinate, and give you the coordinate and ask for the angle, correct? The other thing I can do is tell you that a coordinate is on the unit circle, but you're missing an x or a y. Okay, pencils down, we're listening. In the old curriculum before 2012, when the old curriculum still existed, there was a lot of the same material as there is now. Polynomials was actually in grade 11. It wasn't in grade 12. Radicals and rationals and other functions were kind of dispersed. And we had a unit called conics. Conics was you had to find equations of like circles and equations of ellipses and stuff like that. And then we'd have to transform them using transformation. We don't have that anymore. But what we do know is, I'm going to tell you right now, that this is the general form formula of a circle. Okay? You're not writing this. You're just paying attention. That is the general form for every circle in the entire world. Okay, if I went to go graph a circle, that would be the formula I would use. Just so you know, H and K are the center of the circle, and what do you think R would stand for on a circle? Radius. Right? It would be our radius. Well, what is the radius of the unit circle? We talked about this. It's 1. One this way, one this way, one this way, one this way. That's why we make that little tiny 4-box unit circle that we think is huge, but it's really actually very tiny. Yeah? So we know our radius is 1. What is the center of our circle in the unit circle? 0, 0. So if I go to fill that into the actual formula for a circle of all circles in the world of circles, I would get x minus 0 squared plus y minus 0 squared equals 1 squared. And if I want to simplify that, x minus 0 squared is x squared plus y squared equals 1, which is right here for you. You pick up your pencil. So if I either give you a coordinate on the unit circle or I ask you if something is a coordinate on the unit circle, I would use that formula. It has a radius of 1. correct? So guys, if I took every coordinate that we have, all the exact values on that unit circle, and I put the x in and I squared it, I put the y in and I squared it, it would equal 1. Because the radius of that circle is 1. Remember how I said, yes, there's all those coordinates that we look at, those exact ones, the 30, the 45, the 60, and the 90. But there's also an infinite number of little ones along the way. That's why it actually makes an entire unit circle, because 1 degree has a coordinate, 2 degrees, 3 degrees, 4 degrees, 5 degrees, 5.75 degrees. They all exist around that unit circle, correct? But all of them also have a radius of 1. So if I plug in an x and I plug in a y, and I square them and I add them, and it gets me a value less than 1, then that coordinate would be located on the inside of the unit circle, because it wouldn't have a radius of 1, it would have too small of a radius, right? If I plugged in my x, y, squared them, and added them, and I had a number greater than 1, then that coordinate would actually land outside of my unit circle, because it would have a radius greater than 1, right? So in order to land on the unit circle, you have to be able to square the x plus square the y, and it results in a 1, a radius of 1. So, because the whole circle, when I attach all those coordinates around, it makes a circle with a radius of 1 the entire way through. Okay? So, this one here says, determine the missing coordinate value for each point on the unit circle. So this one gives me an x, the y stays a y, and it's in quadrant 2, and it says it is on the unit circle. Whenever I see this, I use the formula x squared plus y squared equals 1. Okay? So I am going to go negative 4 over 5 squared plus y squared equals 1. I'm just filling it into the formula, right? Now, if I square negative 4 and square 5, I'm going to get 16 over 25 plus y squared equals 1. Then my next step is to subtract that 16 over 25. So I'm going to get y squared equals 1 minus 16 over 25, which you could plug into your calculator, but I'm going to make a common denominator to math it. So I'm going to get y squared equals, instead of a 1, I'm going to go 25 over 25, because that is 1, minus 16 over 25. So I get y squared equals 9 over 25. How do I get rid of a squared? A square root. And when I do this with my arm, what must I always remind myself to do? When I'm physically taking the square root. Not when I write down the square root equation. When I physically take the square root, plus or minus. Exactly. Simon, can you answer that? Just say Mrs. Lepp's room. Go Cruz, you got this. I believe in you. Plus or minus 3 over 5. And then we're in quadrant 2. What is your y in quadrant 2? I can come there.
Okay.
He's not even being paid. Free help. So it has to be positive. What's up?
Call you back after.
Who is she? Do you know?
Someone.
I can. Thank you. You're a really good secretary. You're hired. Solid. Okay. I need 3 over 5 because it needs to be positive. Okay? Because it's in quadrant 2 and y is positive in quadrant 2. Okay? You guys try B. So, we have 3 over 10 squared plus y squared equals 1, which gets us 9 over 100 plus y squared equals 1. And then we get y squared equals 1 minus 9 over 100, which works out to 91 over 100. And then we're going to go back to grade 10 for a few seconds. We go back to grade 10 a lot. So in grade 10, your teacher taught you that you can write an entire radical over a fraction, or you can split the fraction up into 2 radicals. Why would you do that? Well, I would do an entire radical when the entire radical cancels down nicely, like 3 over 5, they're both perfect squares, correct? In this instance, 100 is a perfect square, but 91 is not. So I can reduce the 100, but I can't really reduce the 91, because it's a no. 91 from 100%. 100% en français, pour favor. That is not French. Okay, so square root plus or minus square root plus or minus y. Why did I put an extra plus or minus? Anyone? Euler? Y equals plus or minus root 91 over what? 10. So you split it if one of them is a perfect square and the other one is not. Do you know what I'm saying? Then you're not rationalizing denominators and weird things like that. You also split it if you have to rationalize the denominator, which you would have learned for 20-1 last year. You get an entire radical. Now I need it to be in quadrant 4. So what does my y need to be in quadrant 4? Negative. Okay. Now, I want to go down to example 5. We're going to do 1 in example 5. So we want to know if this is on the unit circle. If I want to know if a coordinate is on the unit circle, what equation should it fit into? The x squared plus y squared equals 1 formula, correct? So remember, in order for something to be on the unit circle, it has to have a radius of 1. Or else, if its radius is too big, it's outside the circle. If its radius is too small, it's inside the circle. But it's not on the circle, correct? So if I take 0.65 and I square it, and I add negative 0.76 and I square it, it should equal 1. It does not. It equals 1.001 equals 1. People are like, yep, that's true. No, it's not. Your unit circle has a radius of 1. This one's is 1.001. It's slightly outside the unit circle. So these are not equal. So this is not on the unit circle.